What's going on, everyone? My name is Al Bryant, and today I'm going to be talking to you about 12 LLM terms that every AI learner should know. Now, whether you're just starting out in your AI journey or whether you're looking for a refresher, understanding these fundamental terms is going to help you navigate these discussions with confidence. That way, when you're hearing all these terms being thrown around, you understand what is being said and you can contribute to the conversation in a meaningful way that's going to help you and those around you actually move towards your objectives that you're hoping to achieve with AI and LLMs. Without further ado, let's get into the terms. We're going to start with the building blocks of LLMs, tokens. So tokens are the fundamental units that LLMs process. One token might be a whole word like hello, or it might just be part of a word like ing, as in running, swimming, or walking. Most models end up processing around 3 to 4 characters per token on average. But why does it matter? Understanding tokens is going to help you estimate costs and optimize your prompts for efficiency. In other words, if you have improper prompts or prompts that just aren't very efficient, you may end up having to use way more tokens than you would have had to use if you would have properly engineered your prompts, which we're going to talk about in this video, prompt engineering. Ultimately, what does it really mean? It really means it's going to drive up your costs, because most models that you consume from a consumer standpoint, whether you're a business or an individual, you get charged based on the number of tokens that you use to process your queries. So tokens become ultimately tied directly to cost. Next up, we have embeddings, or meaning as mathematics. So an embedding is a mathematical representation of words and concepts into numerical vectors. This allows the model to understand semantic relationships and meanings. Let's walk through the process. When you submit a prompt to, let's say, ChatGPT, that prompt takes the words, and the words are then broken down into individual tokens, as we just discussed. Those tokens are then embedded into a vector space. Now, this vector space, for our sake, we can think of a 3-dimensional space like the one we live in. These tokens are placed inside of that 3-dimensional space, but for LLMs, it's actually using multi-dimensional spaces to place the tokens, okay? So once these tokens are placed in that vector space, we call it the vector database, then this is going to allow the LLM to understand similar concepts, because that embedding is going to, just based on the embedding algorithm, it's going to place words that have similar context, that have similar meaning, that have semantic relationship. They're going to be placed closer together within that vector space. Why does it matter? Because embeddings are what enable the semantic search. It's what enables things like recommendation systems that Netflix gives you, because it's looked at who watches this show, they tend to also like this other show that's really close based on just the patterns that have been learned. And it starts to map those out. And that's how it can already know the type of shows that you like before you even tell it, or before you realize you like that type of show. For example, it helps models understand that king and queen are very much related concepts. Moving on to parameters, the neural building blocks. Parameters are the learned numerical weights and biases that form the brain of an LLM. You can think of them as connections between neurons. Each parameter stores a tiny piece of learned knowledge about language patterns, relationships, and concepts. During training, these billions of parameters are adjusted to minimize prediction errors. ChatGPT-3, which was released in 2020, had around 175 billion parameters, whereas one of the more recent models released in 2023, ChatGPT-4, had 1.4 trillion parameters. That's almost 10x in just 3 years. That gives you an idea of how exponentially these are growing. And you can go online and you can go look at the models and see how they've just grown drastically in the number of parameters that the models are made up of. Why does it matter? Parameter count often relates to the model's capability. More parameters typically mean better performance, but it also means higher computational costs. So I think it's important when we talk about parameters to keep in mind that bigger is not always better. What we have to keep in mind when we're talking about all of these AI tools is we have to be specific about the use case and the intention for them, because a large language model may be way too costly from a computational power, space, cooling. From that perspective, a large language model may be too much for what you need. So you really need to focus on your use case, and perhaps you could solve that with a small language model that requires a lot fewer resources but can do your specific task really well. So in this case, bigger is definitely not better. Next up, we have transformers. So transformers are the neural network architecture breakthrough that was introduced in 2017. This enables LLMs to process text efficiently and understand context relationships. So when you hear Chat GPT, the GPT stands for Generative Pre-trained Transformer. The biggest innovation of transformers and what really made it like a breakthrough is this thing called the attention mechanism, which allows a model to focus on relevant parts of the input when generating each part of the output. Why does it matter? Transformers made modern AI possible by solving the problem of understanding long-range dependencies in text. So if you're typing a long prompt, it's going to understand the bottom half of the prompt and how it relates to the top half of the prompt and be able to give you a more complete and a more effective response to your query. Now, we've already talked about how GPT in ChatGPT stands for Generative Pre-trained Transformer. Now we know what transformer means. Let's talk about what it means to be pre-trained. So when a model is pre-trained, we're really giving it the foundational knowledge that it needs. And how do we do that? At a high level, it's a 4-step process. Step 1 is data collection, where we gather massive data sets from books, articles, and websites such as reddit.com and code and any source you can think of. As long as we can have it in a digital format, we're able to use that as part of the data collection process. Once that data has been collected, the second step is actually processing that data. That means cleaning and structuring the data in a way that it could be used to train the LLM. That brings us to the next step, step 3, which is actually training. So once this data is fed to it, it starts to learn the language patterns through billions of examples that are being fed to it based on the data that we collected. Once this training is complete, you now end up with what we would call a foundational model, which means that the model has a broad set of knowledge and can still be used for specialized tasks at that point. When you hear ChatGPT, right, underneath there is OpenAI's foundational model. Meta's Llama is a foundational model. Anthropic's Claude is a foundational model. Why does pre-training matter? This is where the models develop their foundational knowledge and language understanding that make everything else possible, as far as humans being able to interact with it with our natural language and it being able to understand what the task is. All right, so now we have a pre-trained model and a foundational model such as Llama or such as Claude. The next thing we're going to talk about is fine tuning. And this is when you take that general purpose LLM that has been built with broad knowledge, and then you start to feed it specialized data, giving it curated data sets that are specific to your domain or specific to your niche or whatever it is the topic or the skill set that you want that LLM to specialize in. Now that's going to allow you to come up with basically your own custom assistant or your custom AI agent that's going to specialize for particular tasks or for particular industries based on the data that you fed it, in addition to its broad-based foundational set of knowledge. This is how companies are going to create their custom assistants that understand their specific industry, their specific products, or even their specific way of communicating. Next up, we have context window. This is essentially how much text an LLM can remember and work with at one time. So you can think of it as a model's working memory, which will typically range from between 8,000 tokens to 200,000 tokens, depending on the model that we're using. Why does it matter? Because this determines how much conversation history, how big of a document or how much of a document, or how much code the model can consider at one time whenever it's generating responses to the queries or to the prompts that it's been given. The model will essentially forget any information that is beyond this context window. Just to have an example of the context window size of the modern LLMs, ChatGPT-4 has a context window of 32,000 tokens, which equates to about 24,000 English words. Next up, we have inference. This is the process of the LLM actually generating responses to your prompts. This is when the trained model actually thinks and produces output based on its learned patterns and based on the data that it's been fed. Inference is typically the most visible part of an AI interaction for users, but it does represent just one phase in the complete AI lifecycle. Do keep in mind some of the other parts of the AI lifecycle that we've talked about, such as training and fine tuning. Why does it matter? Understanding inference is going to help you grasp why responses take time to generate and how computational costs are determined. Next up, we have temperature. This is going to be how you control the amount of creativity or the amount of randomness that the LLM uses in its responses. So temperature values typically range from 0 to 1 for text completions and from 0 to 2 for image generation. So for text completion, a temperature of 0.1 is going to be really low, and that's going to give you a predictable and consistent response. It's going to be ideal for factual information, for code generation, and structured data. A medium temperature, such as 0.5, is going to allow you to strike a balance between creativity and predictability. It's going to be good for conversational responses and for general content. A high temperature, such as 0.9, is going to be much more creative and give you more varied and more surprising outputs. It's going to be best for brainstorming, storytelling, and creative writing. And that may be what you desire for creative endeavors, and so it makes sense to have it set to something like 0.9. Why it matters. Adjusting the temperature is going to let you control whether or not you're getting consistent and factual responses, or whether you're getting more creative, diverse outputs. Next up, we have prompt engineering, the art of asking. So there are 3 different levels to prompting. You have your basic prompting, which is going to be just some simple instructions that are going to give the LLM limited guidance. Then you can step it up a notch to more advanced techniques where you're giving the LLM prompts that are based on structured formats. You can give it examples, and you can even set specific parameters in how you want it to respond. Then you have expert level prompt engineering, which is going to comprise of complex frameworks that dramatically improve the output quality. Why it matters. Good prompting can dramatically improve result quality without changing the underlying model. That means if someone is doing a good job engineering their prompts, but using a small language model that has fewer parameters, they can get better results than someone who is poorly prompting a large language model. So prompt engineering is going to be one of the most important skill sets that we can learn, because it's also going to reduce your cost and allow you to get tasks completed with the least amount of tokens and to the level that you want it to be done. Next up, we have chain of thought. This is when the LLM essentially shows its work. So chain of thought is a prompting technique where you ask the model to show its reasoning step by step, which often leads to more accurate and explainable answers on your behalf. By breaking down complex reasoning into smaller steps, the model is less likely to make errors and more likely to catch its own mistakes. Why it matters? Because this technique can significantly improve the accuracy on complex problems and prompts, and it's going to help you understand how the model reached its conclusions. That gives you the ability to go back, and based on how the model approaches the task, you can adjust the way you prompted it to get more of the result that you're looking for. Now, we are starting to see chain of thought in some of the more consumer-facing products, such as ChatGPT. You can enable it, and I believe you can enable it for Claude as well. Next up, we have one of my favorite terms, hallucination. Not because I like to hallucinate, but I like the concept and the theory behind why AI hallucinates. So what is a hallucination? That's when an LLM confidently generates plausible sounding, but factually incorrect information. It often fills in gaps in knowledge with seemingly believable details. So what can we really do here? Number one, it's important to recognize hallucinations by looking for overly precise details, contradictions, or information that seems to be too perfect or convenient. If it's too good to be true, you know the rest. How do we prevent hallucination? Using lower temperatures, asking for sources, and implementing fact-checking in critical applications is going to be one way to address or at least reduce hallucinations. We also want verification importance. We always want to verify important information from external authoritative sources. Why it matters. Recognizing hallucinations is crucial for using AI responsibly and for knowing when you need to verify information from external sources. It's going to be helpful to keep in mind that these things hallucinate, and that way we don't necessarily go around taking what we get from our prompts and running with it as if we know it's factual truth. It should cause for a little pause, and that's why we're always going to need some level of human intervention when it comes to working with AI and real-world practical applications. So before this video, you might have felt like Gary Coleman. What you talking about? But now, hopefully, you feel like this guy and you understand it now.